Here we go. What we just taught you on the importance level is up here. What I'm going to teach you now, its importance is like here. Not very important, but it is something that comes up on the ACT. We do refer to it later in trigonometry, and you will see it on this test. Odd functions, even functions. Odd function, y equals x cubed. Even function, y equals x squared. How do you think do you determine if something is odd or if something is even? The exponent, right? You can either put others on here, like then minus x to the fourth. Hey, still even. Plus 1 over x to the fifth. Hey, still odd. Got it? However, there are other functions that are odd and even. For example, y equals cosine of x is an even function, whereas y equals sine of x is an odd function. We can't simply look at the degree in order to determine whether those are odd or even. There's something about the symmetry of the graph that claims it as odd or even. Even functions are symmetrical about the y-axis. Meaning you can flip it across the y-axis, you're going to get the same thing. Odd functions are symmetrical about the origin. Meaning you take the function and rotate it 180 degrees and you'll get the same function. Or you take it and you take what's in the first quadrant, put it in the third, take what's in the third quadrant, put it in the first, and it should be the same. See that? There's a test that we use to determine whether things are odd or even. If you take negative x and plug it in for x for the function, and it produces f of x, meaning the original function, then it's even. If you take negative x and place it into the function, and it produces negative f of x, meaning the same function but negative, then it's odd. Please look at the three examples. Letter A, look at the exponents. Do you think it's odd or even or neither? It is odd. Why are you so confident, Mr. Carson? Third power and first power. Very good. He's right. This is odd. We need to show that it is odd. Those of you who have horrible handwriting, please pay attention here because this is what I need to see on the test. I plug in negative x and I get, with parentheses, negative x cubed minus 4 times negative x. Do you see my work? The parentheses are important that I can see that you're plugging in negative x. Now, let's simplify what's in parentheses. What is negative x cubed? It's negative x cubed. Minus 4 times negative x. Plus 4x. Is that similar to what I started with? Is it similar? Is it the same? It's not the same. So because it's not the same, it's not even. If it was the same, we'd say it's even. So I will try factoring out a negative 1. And when I do, I get x cubed minus 4x. Is that the same as what I started with? Yes. So notice what I'm going to do. Notice how I'm going to end this. I have a negative sign, and then instead of writing x cubed minus 4x, notice x cubed minus 4x is the same thing as f of x. So I started with f of negative x, and I produced negative f of x. You just did a proof. Yep, that's a proof. Yep, didn't even know it. Hannah liked it before. She was like, I like the problem. And I said, proof. She's like, I don't like it anymore. Kind of true. Kind of true. Well, now you're thinking proofs aren't that bad, right? Okay, that's actually good stuff there. Next one, odd, even, or neither. What do you think? It is even because it's 10x to the 0 power, because anything to the 0 power is 1. So you have 10 times 1 is 10. So it's x to the 0 on the end there. So this is even. We will show that it's even by plugging in negative x. When I plug in negative x, I get negative parentheses negative x squared plus 10. Sometimes people say, oh, 2 negatives cancel, make a positive. Can't do that yet. You first must square it. What's negative x squared? X squared. Then make it negative. I get negative x squared plus 10. Is that the same as what I started with? So this is the same thing as f of x. So you've done your proof. You showed that f of negative x is in fact f of x. So that means that it is even. Wow, really funny. Last one, odd, even, or neither. What do you think? It is even. Suppose I switch this and instead of a 1, I add an x. At that point, it would be neither, because you wouldn't be able to get it work out for odd or even. As you see, it mixes even exponents and odd exponents. Can you see the difference? Okay. That's it. Congratulations. You made it through the unit. You are an exceptional class.